Hello and welcome to this very brief presentation on asymptotes, or asymptotes if you prefer. When I say short, it's probably the shortest one I've ever done, so let's get started. Okay, so if you have a look at this is from the y equals Euler's number, the e to the x, so that's 2.71812 to the power of x, and as you can see it follows this line like that, and the asymptote here is on this. It's going towards 0 but never getting there. So for example, if I was to move further and further and further to the left, it would actually never arrive and never touch the 0. It's just getting close all the time. So that's what we call an asymptote, where it gets close and close to a line but never actually gets there. So you could put, if you was to test this in your calculator and put in, say for example 100, you would get a very, very small number for your y value, but it still would never get to 0. If you try anything much bigger than that, you'll find most calculators will just give an error message because it's just too small a number. Okay, so what this one's doing is going towards an asymptote that is on the horizontal where the y is a 0. On our next example, we've got log. Now this happens to be a natural log, but it's the same shape with any log. And this time we've got the asymptote towards the vertical. So the same thing happens here. As we go down, we keep on going down. So this number gets increases quicker and quicker as we go to a smaller value of x. But again, we never touch the 0. So if you try doing a log of a negative number, this is why you get an error message, because it's not allowed. There's no such thing. In fact, if you try log of 0, you'll get an error message because it never touches the 0. Simple as that. So that's another common one. So that one and the Euler's number are well worth remembering, that they always have that shape. Incidentally, on the other side of the scale, then this keeps increasing, keeps going up, but never gets flat. So it's always increasing. Keeps getting nearer to being flat but never gets there, so the number's always greater. That's why this one's not an asymptote. And if I go back up, we've got the same thing here. This keeps getting more and more vertical but never gets vertical, just keeps getting closer, but it's always moving towards the right hand side like that. So that's why that one's not an asymptote. And finally, just to finish off, this one's getting closer and closer and closer to this line here, which happens to be y equals x. So when x is 2, y is 2, and so on, 4 and 4 and so on. So it keeps getting closer and closer and never touches it. So if I zoomed in and zoomed in and zoomed in and then kept going up, I would see that, in fact, let's zoom in. Basically the two lines would never touch, and that's as far as it'll let me zoom in by the looks of it. So if we had perfect image, perfect quality, two thin lines, we'd still always end up with a gap between them. Okay, so that's it. That's a very basic introduction to asymptotes. So thank you for listening.